Welcome to my student. Now today's lectures. We are going to discuss the topic surface tension. Now in this topic we have studied the various methods are used for determining surface tension as well as viscosity of the liquid. Surface tension are measured by drop number method. The drop number methods are used to measure number of drops formed from a fixed volume of the liquid. This fixed volume of liquid can pass between the two marks capital A to capital B. It is determined by using the instrument, and this instrument is called as Trout stalagmometer. Trout stalagmometer. The lower portion of stalagmometer, it consists of a fine capillary tube through which the liquid can flow, and upper portion it can connected by rubber tubing having Y-shaped glass tube. So this stalagmometer now is here like this. So this is a capillary tube. It is a portion A and portion B. It is a rubber cork. It is a Y shape. It is pinch cork and screw clamp. After sucking the liquids, the pinch cork is a fit and screw clamp getting open. Such a type of operations now we have see is here like this. So firstly, this is the stalagmometer having fine capillary tube and liquid can flow. The upper portion Y-shaped glass tube. But at the starting of the experiment, firstly, what happens? The screw clamp closes and the given liquid is sucked into stalagmometer. Right? What is the firstly, the screw clamp closed and the given liquid is sucked into stalagmometer at the level mark A, up to mark A, by opening the pinch cork, and then pinch cork is closed and screw clamp gradually open. So the number of drops flowing out between 50 to 20 per minute, right? 50 to 20 per minute. Once this drop rate is achieved, the screw clamp is left undisturbed, and then liquid is again sucked by opening the pinch cork without allowing any air bubbles to remain in the capillary. Then the number of drops formed by flowing the liquid from mark A to B. So this number of drops formed by flowing the liquid A and B can be determined. So how will you determine this? Now let us consider the number of drops is denoted by N1. If 2 pi r gamma 1 cos theta is the force can affect on the water due to surface tension on a single drop. So such a force can affect the water drops. Then the force on N1 drops will be this 2 pi r1 N1 cos theta. Then this latter force will have be balanced by the weight of the drops of N1, which is M1G, and M1 is the mass of the N1 drops, right? And hence M1 is the mass of N1 drops. Therefore, this M1 is equal to this M1G is equal to twice pi r1 n1 cos theta. Therefore, twice pi r gamma 1 n1 cos theta is equal to capital Phi into rho 1 g. You know that mass is equal to density into volume, right? Or density is equal to mass upon volume. So we can put up this relation. So mass is equal to volume into density. So volume into rho 1. So where this V is the volume of the liquid can flow from the mark A to mark B, and rho 1 they will be density of the liquid. The stalagmometer is then clean and dry, and the same procedure is repeated with another liquid of measure the surface tension at the gamma 2. Let the number of drops obtained with this liquid is denoted by N2, right? It's denoted second liquid. The number of drops can form is denoted by N2. Then, therefore, mass of the second drops will be M2G is equal to twice pi r gamma 2 N2 cos theta. So similarly, the mass is equal to volume into density of the second drops. So pi r gamma 2 N2 cos theta is equal to volume into rho 2 into g. Right? From this equation 1 and 2, we combine twice pi r gamma 1 n1 cos theta upon twice pi r gamma 2 n2 cos theta is equal to P into rho 1 upon P into rho 2. For those, if n1 and n2 are the determined also densities of the two liquids, right? Densities of the two liquids, then surface tension of any one liquids can be calculated if that of the other liquid can be known, right? And therefore we can cancel as like this is 2 pi r gamma 2 pi r will be cancelled, 2 pi r will be cancelled. So gamma 1 upon gamma 2 they will transfer to here, so gamma 2 upon gamma 1. Similarly cos theta will be cancelled, and remaining n1 upon n2 is equal to, it is also v will be cancelled, g will be cancelled, so rho 1 upon rho 2 into these terms can transfer is here, gamma 1 upon gamma 2 is here, so how will you change gamma 2 upon gamma 1, and therefore we measure this gamma 2 is equal to, how will you measure this gamma 2? Gamma 2 is equal to this n1 upon n2 into, right, rho 2 upon rho 1 into this is gamma 1. Therefore, the unit of the force is Newton, which acts as surface of the liquid at right angle to any of the unit length having the 1 meter. Therefore, surface tension has the unit is Newton per meter. Right? Unit of the surface tension is Newton per meter. Now, next points we are going to discuss as like the viscosity. Viscosity, it means that the resistance that one part of the liquid flowing with the certain velocity offered to the another part of the liquid flowing with different velocity. Right? Now we have considered the liquid can flow from a tube, and therefore liquid flowing by this tube which is not equally. It means the different liquid flowing with different rates, and therefore the velocity of each layer in the liquid will be different. It means that the layers at the side of the liquid will move with lesser velocity as compared to center. The center layer of the liquid is fastly move as compared to side layer of the liquids. But velocity of liquid is measured in terms of coefficient of viscosity, and they are represented by the Greek letter is eta. Right? But some of the factors also they will affect on this viscosity of the liquid. First one is the nature of the liquid. Right? Now, firstly, this is a nature of liquids. It means which type of the liquids are there. Second point, substance with larger or heavier. Sorry, lighter or heavier. Substance with lighter or the heavier. It means that the substance with the heavier emit greater resistance to flow and hence have high viscosity. Right? Next point, spherical molecules. They will have less resistance as compared to the rod shape or plate shape or irregular shape. So these molecules have the more viscosity as compared to spherical molecules. Spherical molecules which are the very less viscosity because it is moved very fastly. For examples, in these spherical molecules, right? Next point, straight chain molecules. They are less viscous as compared to branched chain molecules. Branched chain molecules are more viscous than straight chain. Similarly, polar liquids, right? Polar liquids are more viscous than non-polar liquids. Polar liquids are more viscous than non-polar liquids. Why? Because polar liquids forms the polar bonds, right? But non-polar liquids does not form bonds, and therefore the polar liquids are more viscous than non-polar liquids. Next points, higher the intermolecular force of attraction between the liquids, higher the viscosity. Right? So intermolecular force of attraction also affect on the viscosity. It means that the intermolecular force of attraction between the different molecules is more, then the viscosity is higher. So this is a diagrams for the stalagmometer, and these stalagmometers mainly used for to measure the drop number methods. It is also to measure the surface tension by using drop number methods. Right? The next points now we are going to discuss as the coefficient of viscosity. Right? Suppose a liquid of area of square per centimeter is moved over another liquid layer having a similar area at a distance x with a velocity difference v as per second. and F is the force can require to maintain the constant difference of velocity. They will be given by is directly proportional to, inversely proportional to AV upon X. But if X is equal to 1 centimeter, volume is 1 centimeter per second, and area of cross section is equal to 1 centimeter square. Right? Then the F is equal to eta into A P upon X equation 2. And therefore eta is equal to, so conversion of this equation, so eta is equal to F into X cross multiplication, F into X upon A phi, and therefore X is equal to 1, A is equal to 1, P is equal to 1, and therefore eta is equal to F. So eta is the coefficient of viscosity. The coefficient of viscosity of a liquid may be defined as the force per unit area. Right? Coefficient of viscosity is defined as the force per unit area, which is measured in dynes per centimeter. To require to maintain unit difference of velocity 1 centimeter per second. 1 centimeter per second. Between the two consecutive layers of the liquid 1 centimeter apart. Right? The coefficient of viscosity can be expressed unit as poise. Right? Viscosity. Unit of viscosity is expressed as a poise. And the relation 1 poise is equal to 1 dynes per second 1 poise is equal to 1 dynes per second centimeters per centimeter square. This is very important. This asks in this exam, like the 1 poise is equal to 1 dyne per second per centimeter square. Right? Okay. Thank you.